All right, so my name is Anthony Bettini, founder and CEO of FlawCheck. Just a quick bit of background on myself. I've been in security since 1996. Started by doing forensics for an ISP that was compromised. All of their billing database was in a core file. Someone debugged that, posted it to Usenet. All the credit cards drained. That's how I started in security a long time ago. Have been doing vulnerability research and stuff relating to vulnerability research, reverse engineering, malware analysis, all of these kinds of things since that time. So just a quick bit of history on Linux containers and all the stuff that's kind of led into the containerization technology inside Docker and things like Docker. I think in general, looking at history is pretty helpful for stuff like this. Like if you were in Job DeHaas's talk in this room yesterday, actually, they spent a lot of time on basically porting hardware attacks, like cryptanalysis hardware attacks, into software. And I think it's like really relevant, when you look at containerization technology, even if that's like comparing Adobe Reader X or things like that to Docker. And we at FlawCheck actually spend a lot of time thinking about containerization technology as it applies not to digital containers, but shipping containers. Because much of the same problems found in shipping containers we actually find in digital containers. And how would you address those problems, we think is pretty similar as well. So starting out with containerization technology on Linux, the earliest thing we could find was chroot. Won't spend a lot of time on this, but just the basics refresh on chroot. It's back from '79. I never realized it was that old myself, but that's how old that is. If you chroot to a folder, you create like a directory. You have to have bash in the directory. You have to have anything you want to execute in that. And a long time ago, maybe 10, 20 years ago, people thought chroot was for security, but really wasn't. It was for creating a jail for something like FTPD. And if you copy bash into chroot, ultimately you have to copy in all the dependencies, all the shared libraries, all these kinds of things. And like any other old containerization technology, there's breakout attacks for that. You can just recursively change the directory up, and you can break out of a chroot. To get to the next kind of precursor technology, you have to fast forward quite a lot, actually. So going from 1979, it jumps to 2007 with the introduction of C groups. So C groups API interface in the kernel. Largely implemented actually by Google engineers, and what was kind of interesting about that is what their aim was coming up with this idea of process containers. And they didn't want to call it process containers because even at the time they felt containers was an overused term. But ultimately what they were trying to do is, if you think back to Google 2007 kind of time frame, they're scaling up and they want to isolate all the processes and keep everything separate. And so they start pull requests on the kernel to add C group support. And then kind of the first kind of larger reference implementation for all of the container interfaces in the kernel was actually LXC, so only about a year later. And then LXC starts providing a reference implementation on kernel namespace support, on C groups, AppArmor, SE Linux, policies, all these kinds of things. And this ends up being effectively some level of a precursor to Docker itself. But then Docker actually comes much, much later. So that's actually only a couple years old at this point. So it was introduced by Solomon Hykes at PyCon. And that was actually a lightning talk, oddly enough. It's such a popular technology, most of the people in the room have now used it. It was introduced at a 5-minute talk. And certainly would encourage people to watch the talk, especially if you're into security, you're into containerization. You can tell from the talk that the team behind Docker certainly new to security, but had put tons of time into containerization. And the reason they put all this time into it was they were running .cloud. At the time, you can think of it like Heroku if you're not familiar with .cloud. And they were trying to run effectively arbitrary web applications in the cloud while generally trying to keep everything separate from each other. And if we were to compare Docker to LXC, I'm not sure how visible this is in the back, but what's kind of interesting, LXC basically started by being really similar to effectively virtual machines. But Docker wasn't. And the reason it wasn't was because of the copy on write file system. And so what ends up happening with Docker is you effectively have process containers instead of operating system containers. And because of copy on write and a layered file system, you can turn on containers very quickly. And so the basis of that at the time they were starting was AUFS. Now they have like a whole tree of supported file systems. It's not necessarily AUFS all the time, and there's all these asterisks next to it, like Red Hat not supporting that in the mainline kernel, all of these kinds of things. But what's kind of interesting is, like, if you look at a Docker image, it's effectively a layered file system. So you can think of it as a tarball, but you untar this tarball. There's a whole directory structure below that, and there's this copy on write file system. Let's kind of burn through this since most people have used Docker. But this is just quick basics on Docker. So you can pull from Docker Hub, which effectively is like Google Play, but for Docker, so it's pre-built container images. You download this container. You can then run it. After running it, you can launch a command in the container like ifconfig, pull your IP address, verify it's different from the container host itself, exit the container. So this actually starts getting pretty interesting. So if you were looking at like hypervisors like vSphere, things like this, it's not a very open system. And they would certainly claim they have APIs, all of this kind of thing, but it's quite different from Docker, where you can just download it, look at the source code, there's APIs into everything. And why that starts being interesting as a comparison to something like vSphere is like what we would think is that in the future, people will certainly write rootkits, backdoors, things like that against the Docker socket API and the remote API, because you can end up having effectively full control over data centers that are based on Docker. And for the customers we talk to, that is actually the kind of thing that's coming soon. And what's interesting is, whereas like if you were to look at vSphere, which is the predominant hypervisor technology in the data center, the APIs on that are very limited. So it's very unlikely that you would see like a backdoor or a rootkit show up on something like vSphere, whereas on Docker, that's actually incredibly easy to do and very likely to happen as Docker becomes prevalent. So one of the main technologies at this point that actually is used by Docker is actually the fundamental thing behind Docker's containerization technology is Linux namespaces. How many people in the room have some sense of how namespaces work? Okay, great. So basically you can think of a namespace as some level of a container, and then the namespaces, there's like you can effectively have like a namespace for processes, for mount points, for networks, for users, all of these kinds of things. I think this slide might even actually be like too dated at this point, but like just a week ago or a week and a half ago, Docker did actually implement support for user namespaces. But I think that's in like the latest release, and I'm not sure if that's actually like hit the public yet, or it's like one release out or something like this. But user namespaces is where you can start guaranteeing that the process ID inside the container of the process that's running is different from the Docker daemon, which is actually running as root. So next we'll just cover kind of like a quick state of the union on enterprise usage that we actually see. And all of these things, on some level you could say like don't relate to the topic of exploitation, but the reason we think it's largely important is like how you would exploit Docker and how you do today, how you would in the future, all relates to like how does the Linux containerization technology work? How did we actually get there? What's coming? Who built it? What did they build? And then how do enterprises actually deploy and run Docker? So one thing that's kind of interesting, certainly we're seeing this change over time and kind of ramp up, but The backdrop would be that every enterprise we talk to of any size, any magnitude, virtually 100% of them already run Docker. But the asterisk next to that would be they're typically very small deployments. They're typically not in production. They're typically, developer here and there, team here and there, this kind of thing. But what ends up happening, like you can imagine a large financial institution, they Dockerize some application, they try to push that to production, and then the IT security operations team says, what the heck is Docker? And so then, there's effectively a pushback, and then they want to figure out, like, is the application safe or not? What did you do to improve the security of it? What have you done to validate that you're not going to put the company at risk? All these kinds of things. And because typically the developers using Docker don't have good answers to those questions, typically it's not reaching production. But everyone effectively in the Docker ecosystem, which is a ton of companies at this point, of like every operating system vendor, everything, they have a lot of vested interest in seeing Docker reach the data center and reach production environments. And so then they're putting out all these surveys, like this is Red Hat commissioning Forrester, basically saying to enterprises, why are you not already running Docker in production if you're already running it in different teams within your company? And 53% of respondents said they're not running it because of security concerns. And that was from January this year. So this is actually a more recent survey, basically just re-asking the exact same question. So this was Cluster HQ saying, why are you not running Docker in production? And actually there was an uptick. Even more people said the reason was because of security. So we actually did our own survey about this, asking enterprises, why are you not running Docker in production, containers in production, all of this kind of thing. And asking one level deeper. So not just, is security the top concern, but which piece of the security problem are you actually concerned about? And what we found was actually the concern was actually about vulnerabilities and malware being in the container. So what's really interesting about that actually is that the third concern, isolation, actually meant only 16% of enterprises were concerned with isolation as a security pain point with the containers. And what's kind of interesting about that is if you go talk to the containerization companies like Red Hat, Docker, CoreOS, they're spending virtually all of their time on the isolation problem. But that actually isn't the top concern of the people who say that security is the reason they're not running containers. The concern they have is actually about the vulnerabilities and malware problem, which is actually a problem that's, if you look at the virtualization analogy, VMware certainly never addressed that problem. Docker, Red Hat, CoreOS, these companies are unlikely to address that problem. Yet that's actually what's holding enterprises back from running containers in production. And we've heard all sorts of kind of funky things from people talking to them about containers and production environments and containers in the data center and all this kind of thing. Like one kind of interesting fact, I assume most people are aware of this, but at Google they claim they're turning on 2 billion containers a week. Obviously they're turning them all off as well, but they're ephemeral. So what's happening is, unlike a virtual machine that could have an uptime of 180 days or something like this, the average container uptime is about 3 days. So that impacts exploitation, security vulnerabilities, all this kind of thing, risk, malware, how you would write that stuff, how you would backdoor it, how you would do data exfiltration, because with a 3-day lifetime, it's quite different. We've even talked to some people who said that they got advice from an unnamed billion-dollar company invested in containerization that said you should just shut off your containers every 5 minutes. That'll make you safer. All sorts of crazy stuff out there. So just a bit about kind of like survey of vulnerabilities in the field affecting containers. So some of these are kind of funny or tongue-in-cheek, I suppose, but to anyone who's installed Docker, this is how you install it. So you curl something, you pipe it to a shell, and you put in your root password. I personally think that's kind of funny. So, I feel like that's from like 1993, but in Docker, everything runs as root. That's another awesome one. This is just quick basics on Docker networking. So if you are inside a container, so suppose, and why some of this is interesting too, the backdrop of this is we hear all the time stuff like the containers, like if a container is compromised, it doesn't actually matter because there's only one thing in it and it'll die soon anyway. There's all sorts of reasons why that kind of thinking is wrong, and yet we hear it all the time. So this would be one quick, simple example, is if you're on container A, you can see all the IP addresses, host information for all the other containers on the same container host. So if you are thinking about like EC2 in AWS, the analogy there would be you turn on a virtual machine, an AMI in Amazon, and you can see all your neighbors. Certainly in Amazon you can't do that, but that's how Docker works today. So if there is a compromised container, it can see the network config, like the IP address assignment, on all the neighbor containers. So this gets kind of funny too. So how Docker works with namespaces, effectively the namespaces keep everything separate. I mean, you can think of that as like some basic abstraction. And so if you configure it wrong, which we've certainly seen many people do, this is actually a warning message on the Docker website that's buried 15 links down or whatever. But we've certainly seen people in the wild actually do this, where if you configure it wrong and you do like host-only networking, suppose there's a compromised container, if you actually shut down that container, it'll actually shut down the host and all the other containers on it. Even Docker warns you not to do this, but we've seen this in the wild a bunch of times. So this was actually the first vulnerability that was published with actual exploit code on how you break out of a Docker container. So this is effectively attacking the isolation behind Docker. So at one point, Docker actually had a blacklist for kernel capabilities. So if you take a step backward, what containers are actually doing is unlike a virtual machine where all the operating system images have their own kernel, and then there's a hypervisor kind of keeping everything separate, how containers work is they're all sharing the kernel on the parent container host, and then there's basically, I always think of it as a syscall proxy, but this is not exactly what's happening. It's like the kernel containment API interfaces. But that are effectively proxying all the stuff back to the kernel and keeping everything separate. And so how Docker originally implemented that was having a blacklist on kernel capabilities, and of course they missed some. missed blacklisting some that were pretty important, and so then there's a breakout attack and all of this kind of thing. They've since switched to a whitelist model, so the exact inverse. Certainly a smart decision, but what that does is they've specified which kernel interfaces are okay to call, and then if it's not on that list, it's not okay. And so that limits the attack surface area for interface into the kernel on the container host, which is certainly a good thing. So this is kind of interesting. There actually wasn't public exploit code released for this, but I think this is actually if you were to attack the Docker system, this is actually the most highest ROI place to spend your time on, is all of these decompression algorithms, because what ends up happening, so this is a guy, he finds a bug 0-day in the XZ decompression parser in Docker. And because Docker is running as root, if you compromise, like the Docker daemon is running as root and everything is all this daemon, if you were to compromise the daemon, you have root on the container host, you effectively there have compromised not only the container host itself, but all of the containers because of just how namespaces work. And so that actually was done on XZ. And I don't know how many people have like looked at compression algorithms before. Most of them are terrible, and so if you that's a very easy place to do file format fuzzing as well as like collect thousands of tar files, flip bits, run it through Docker. I don't know if that's how they found the XZ bug or not, but that would be the easiest place to attack the Docker daemon at this point, and probably will be for the foreseeable future, because they, like in some cases for a while, I don't know if they still do this, but for a while they were actually just shelling out to the tar command. But I think they wrote their own like XZ parser and gzip parser, and I think they support a few other decompression algorithms as well. And that's because if you look at the container images, they're basically tar files with then directories, and then there's tar files in them. But you're not limited to tar, and so some people are like compressing, let's say either the root or parent container image file in some alternative compression format, or possibly the layers on the inside. And in some cases, it's compressed multiple times, and so that would be a high-profile attack vector. This is another kind of interesting one. Kind of relates to a few other things, but the shell shock bug. A lot of people think it's way overhyped. Totally agree and everything. But one thing that's kind of interesting about that bug in particular is if you look at Docker Hub, which is where the majority of people are getting pre-built containers, almost all of them have bash in it, way over 50%. And I would then posit that way over 90% of the 50% have old versions of bash. Certainly we see Docker containers from Docker Hub that are vulnerable to the shell shock bug pretty much all the time. And then exploiting shell shock on a Docker container would be no different than exploiting it in a VM. Just what's interesting, though, is that in the case of Docker specifically, most developers are just getting pre-built containers from Docker Hub, and then those pre-built containers typically have vulnerable versions of bash. This is actually the first. I thought this was kind of interesting. A lot of people ask, like, have there been breaches of Docker environments, all of this kind of thing. For one, we're all aware that not every day do you hear about breaches, and that even though they happen every day, and then further, you wouldn't always happen about like what was breached, where was it in the data center, what software was it supporting, what was it not supporting. But this is the first one we could concretely find that was a Docker-based breach. So this is like Ben Hall, who works also at Uproar, a UK company. He had turned on a Docker container, was running Elasticsearch in the Docker container. I'm not sure how much time elapsed, but next time he looked at the Docker container as part of a botnet. And there's Metasploit plugins available for that. And so for that reason, highly likely to happen again. So at FlawCheck, what we do, we actually spend most of our time on this problem of tearing apart containers. And just a bit of analogy on like why we even do that. So Docker Hub didn't get launched until 2014, pretty recent, a year ago. Google Play, long time ago, 2008. If you look at Google Play as a modern analogy or metaphor to Docker Hub, when Google Play first started as the Android market, there was no security inspection of anything uploaded to it. If you think about that now, it seems crazy. Today Google's performing static and dynamic analysis of everything uploaded. Now you could question whether they find anything, whether, total waste of their time, all of these kinds of things. But they do it, and they do it because they have a malware problem. And they're likely to have one for the foreseeable future. And I would posit that the reason they have a malware problem is basically because of platform popularity. And then, of course, it's like, especially over the distribution of users, it would be like high-value data, all of these kinds of things. But ultimately, the two systems, Google Play, Docker Hub, in my mind, is like highly analogous and very similar to play out in the same kind of pattern. But jumping into a couple of the differences, in the case of Android malware, it's all APKs, it's all custom to the Android platform. In the case of Docker malware, it would actually be ELF malware. And for a long time, there's a very little ELF malware. And I would say in my mind, that's slowly changing. Even yesterday there was a talk by Monapa. I saw that talk, the Linux malware Limon sandbox talk. There's still, in the grand scheme of things, small amount of ELF malware. And in this particular case, it was the first I heard of where ELF malware actually turned into a botnet. These were actually security cameras that were running Linux. I'll admit I'm not sure how the malware actually showed up on them, but it was actually ELF malware for ARM, nonetheless, that actually showed up on these security cameras, turned them into a botnet. The world melts and all this kind of thing. But I would say ELF malware is certainly getting more common. And then this is just a bit on Docker Hub and like why we think this relates to the Google Play issue. So Docker Hub overall is something like 15,000 pre-built containers. You can just go get a container for Ubuntu, for MySQL, whatever you can possibly think of that runs on Linux. I think when I built this slide, it had 500 million downloads or something like that. I think they're already over 1 billion. They don't do any security inspection of any kind. Don't check for malware, don't check for vulnerabilities, don't check anything. And someone did a random sampling of containers on Docker Hub. I think a small consulting company. They found that over 30% of containers had vulnerabilities. At FlotCheck, what we did was we actually analyzed the official images. So this is a little bit different. So there's 15,000 of these pre-built containers. Possibly the number is much bigger, but whatever, some number like 15,000. There's also these official images. So what that means is on Docker Hub, you could get MySQL built by some random person. You yourself could build MySQL, post it to Docker Hub. But if there is an official MySQL Docker file that's building an official MySQL container image, and then those have tags by version. So what we did was just check the latest version of these official images that have some blue ribbon seal of approval from Docker. Much like the overall population, they don't do security inspection of the official images. So actually official images is based on some level of reputation of the developer deemed by some employee of Docker. Highly arbitrary in my opinion. What we found on checking those official images, over 90% of them had vulnerabilities. Now those official images have download counts in like the hundreds, like, 10 million downloads or something like this. Because you can imagine someone getting the latest version of the MySQL container off Docker Hub is pulling that image. How many people are doing that? 10 million people or something like this. But what ends up happening is if you do that, you are then downloading an image that comes pre-built with vulnerabilities. And then we look into why, of course. So what's ultimately happening is people are using like old versions of OpenSSL, old versions of Bash. They like build it with an operating system layer, Ubuntu or Debian or whatever that's old. And then they're not doing updates to that very often. And then they're just assuming, built it once, I'm all done. But what ends up happening is someone at a large financial institution downloads that, thinks it's the official latest whatever version of MySQL, and thinks there isn't a problem, but of course there's like tons of problems. So I'll just show a quick video demo. So what this is doing is downloading, this is doing a Docker pull on MySQL. I already have all the layers for that version of MySQL, the latest version. And then this is exporting it out of Docker, just doing like a Docker save on the image ID. This is just SCP machine. This is just uploading it from the portal. And so this only take about a minute. The slowest part is actually the upload process. But I sliced out the majority of the time. Probably the upload itself is taking about 1 minute, fairly large file on a slower network. But the analysis time, that's the second range. But so we did it. So we scaled up the process of checking Docker images for vulnerabilities for malware. In the case of Google Play, in the Google analysis for security risks, so this is just going up on a quick report. I'll just show a version of this. It's like much more interesting. Okay. So this is a couple of things that's interesting. So one, this is the latest version of the MySQL container off Docker Hub, fairly current. And even this latest version of the MySQL container on Docker Hub has like so many vulnerabilities and so much data that it's like scrolling forever. And so one reason there's so much data here is it's actually showing like all the vulnerable binaries, because what's happening in the cases where it's a very long list is actually there's glibc vulnerabilities, and since everything is like built off glibc, it's like a poison tree problem. But there's also vulnerabilities in, let's see. Yeah, these ones are glibc. Yeah, bash vulnerabilities. No SSL vulnerabilities. Anyway, so what we're checking for in these containers, we're checking hundreds of thousands of containers at this point for vulnerabilities and malware. They're likely to impact enterprises. In this case, it's like MySQL container. I can just check by CVE count. Yeah, it's probably about half the number of 56 because there's a bit of like duplicate data, but yeah, just the latest version of MySQL containers, straight off Docker Hub, something like 30 vulnerabilities or 28 or whatever it is. And so the impact to the enterprise, of course, the impact to security, of course, is you run these unsafe containers in the data center, you put them on public IP addresses, the chance you're compromised is fairly high. Now granted, in the case of something like Bash, that like the shell shock bug, you have to have some CGI script that's somehow passing stuff to like the Bash environment variables and like all these set of circumstances. And potentially in containers, you would have a vulnerable but dead code, or a vulnerable but code that's like not bound to any port, not network accessible, all these set of circumstances that like de-risk the problem. But generally speaking, if you are a large enterprise, you want to be running vulnerable code or turning on containers or scaling up applications that have vulnerable code in them, certainly I think you wouldn't. And then comparing this a bit to the Google Play Docker Hub situation, I think what's kind of interesting in a different way about this is the Google Play problem is largely a malware problem at this point. Certainly Google's not trying to go down the path of inspecting for like vulnerable code in some like mobile app. The chance that that's going to be exploited or that they think of that as their problem is significantly low. So their problem is effectively a malware problem. In the case of Docker Hub today, I would say it's actually the opposite of that. So we are checking Docker Hub for malware. We're not finding any yet. That's good. I think that's temporary though, since they're not checking, and they have a pretty loose policy on who can post to Docker Hub. The chance that there's no malware in Docker Hub for the foreseeable future is incredibly low. But we're not finding malware today in Docker Hub. But what we are finding is like over 90% of the Docker Hub container images that come pre-built and ready to go do have security vulnerabilities. And they typically have a lot. So we're seeing an average of like greater than 20 vulnerabilities per container. Now, I would probably cut that way off and say most of those vulnerabilities aren't actually exploitable. But a whole bunch are. Examples where they would be like web tier containers, typically are including old versions of OpenSSL. We see like Heartbleed all the time. We see shell shock all the time. So I think today what's interesting is Google Play is a malware issue, malware problem. Docker Hub is a vulnerability problem. Ultimately, they both have both, but it's like a seesaw weighted in two different directions. And that's pretty much all I had presentation-wise. Would love to open up to questions. But about Black Hat sound bites, one thing we think is kind of interesting is that when we talk to enterprises, what actually holds them back from running containers in production is vulnerabilities in malware. Yet all the companies we talk to on the container side seem totally disconnected from this problem and spend all of their time on the security isolation problem. Which, frankly, if isolation isn't provided by containers or isn't solved, there's effectively no reason to even run containers. So it does make sense that they spend their time on this. But for the large enterprises we talk to who want to run like Docker or some competing containerization technology in the data center or in many data centers, the isolation problem is not the top problem in their mind. And then another thing that's kind of interesting is the flip side of this is we hear all the time, like, because Docker provides isolation, we're safe. But I think, a lot of kind of interesting things play out in reality. Like one is if you have a compromised Docker container, that compromised container has like some visibility into what other containers are present on that same container host. Like just whether that's like networking and host information. And then if you have like a web tier container that's like processing credit cards and that web tier container is compromised by shell shock or who knows what, the person who's compromised that container now has all of the credit card data that's passing through that. And even if that's only happening for some ephemeral container for 3 days, or even 5 minutes because someone keeps shutting off and turning down containers. Obviously, like malicious client code can reconnect every 10 milliseconds or whatever if it needs to. And so any important data that's going through that container, if the container is compromised, all of the data is compromised. And then specifically, if you're downloading pre-built containers from Docker Hub, which literally every company we've ever talked to, when they get containers, they're getting them from Docker Hub. Now, granted, the asterisk next to that would be, as they start realizing that all of those containers are vulnerable, they start rebuilding all of those containers from their own code bases and start doing inspection on them and all of these kinds of things. But like literally what we've heard, without naming names, would be like if Docker is talking to a large financial institution, Docker would tell them, you should just go get pre-built containers from Docker Hub. It's faster, it's cheaper, that's what your developers are doing anyway. But it doesn't mean it's actually safe to do. And from what we see is like over 90% of the containers that anyone downloads or that are important actually come pre-built out of the box with vulnerabilities. And so I guess that's all I had. Any questions? It's a really short list. Actually, the easiest way to get that list is to sort them by file size. So something that's kind of funny is most of the Docker containers are greater than, I'd say, like 250 megabyte. And so if you imagine like 250 megabyte of like Linux binaries and shared libraries, the chance that there's some vulnerability in there is like 99%. There's a very tiny number of Docker containers on Docker Hub that have they're effectively true microservice containers that have like, one binary that's statically compiled against a short number of libraries. Into those containers, we pretty much never find vulnerabilities in. So I would say that the cheap and easy way to get that would be sorted by file size. Yeah? Yeah. Okay, great.
If I can get like a similar situation, is that what I understood from your talk is that the responsibility of reliability shifted to the developer. Compared to middle place, like telling that who is responsible for the security of each application that are uploaded within the middle place. So that's the main sound that I understood actually from your presentation. And I just wanted to pinpoint something about the networking side. It's actually isolated to some of the good options.
Oh, yeah. That's true. I totally agree.
I understand that by default you can have access to everything.
Right.
That you have control on the network.
Right.
That, the whole point of Docker is that the layers for the pre-built containers, you can actually rebuild them.
Right.
You cannot push like a pre-built container that you download from the internet to your production. You have to specifically analyze it and understand what happens behind it. About security and vulnerabilities, actually, what I understand, if the results that you get after the analysis is that the responsibility of security is completely shifted to the users and developers. So it's not, I don't think it's more about like a thought than anything else, because you're like specifying security for developers and they're responsible for their own like security of the containers as soon as they push it through the button.
Well, I would say, so I'll respond. So a couple of things. I wouldn't say that I truly believe either Google or Docker Hub are responsible for security in either case. I would just say that if you look at Google Play, just take that analogy to start with, you would certainly prefer to get non-malicious, safer apps. As a user, as a company, you would prefer that. And so similarly, Google would prefer to not be in the news about malware showing up on Google Play and having millions of people download it. And so that's one thing I'd say. I wouldn't call them responsible. I would just say everyone on that side of the equation has a vested interest in there not being security problems on Google Play. Now, jumping over to Docker and using that as like a similar story, Docker has a vested interest in seeing enterprises, I'll just say enterprises, developers, users adopt Docker. And one way they get adoption is by having Docker Hub and having these pre-built containers. So like if you look at like CoreOS Rocket, like competing containerization technology, I would posit one of the reasons, one of the main ones, those have not taken off is because they have nothing akin to Docker Hub. Meaning like Docker Hub, you can get going much faster because everything is just pre-built and sitting there and ready. And so they can get adoption going up much faster if people use Docker Hub. And so I wouldn't say they're responsible for security problems. I'm sure they're not even spending time on the like vulnerability inspection or malware inspection of Docker Hub. But I would say that if their target customers believed that Docker Hub was unsafe to use, then they wouldn't use it. And that would, or they would, they either wouldn't use it or they would change how they use it. In either case, that's not necessarily good for Docker. Meaning like if they don't use it, it's not good because the whole reason Docker made it was to speed up adoption. And if they change how they use it, maybe like they add like a 10-step process to that, like what you said, like cleaning up the container. I think that's the state of the union, like they have to do that. Because of the problems with the pre-built containers. But certainly, let's say the containers were all safe, were all clean. A lot more enterprises would be using them, and it would be faster for them and stuff like this. So I don't see it as like they're responsible, either Docker or Google. I would just say the enterprise, the developer, we all have the same vested interest that the code we get is safe. Yeah. That's a good question. I'm not, frankly. I'm not. Someone recently asked me at a different conference actually about analysis of OpenStack images and this kind of thing. I'm not aware of any public analysis of that either. Yeah.
Did you find vulnerabilities that are built in new, or only because the software that's in the Docker container is not updated and the lib's not updated and everything, the old vulnerabilities that are known?
Yeah, I would say 99% towards old vulnerabilities that are known.
So for example, this example of Raven, I think you don't only build files with the no complete virtual machines. So you have to for complete virtual machines. But then you have first request an update of the system to one, and then the vulnerability is gone.
Yeah, that's actually a good point. Is it so in Vagrant?
Yeah. If you make the update
Right.
regularly, yeah, nearly gone.
Right. Yeah. So that's a good point. Is the updating of Vagrant images. So in the case of Vagrant, typically, it wouldn't surprise me if, or like I think it's at least a very common use case that as you get a Vagrant image, like first thing you do when you run it is update it. I have seen a lot of people who are downloading stuff off Docker Hub and then not changing it, not inspecting it, not editing it, not updating it, or they're waiting for the update based on like a Docker file update, which doesn't necessarily come so often. And because it's a layered file system, they could be using like a new Docker file, but it's still using like an old Ubuntu layer. And then that old layer still has vulnerable code in it. And then stuff is still linked against it. Right. Any other questions? All right, I guess that's all. Thanks.